You ever just look up at a massive skyscraper and wonder, how? How is that thing not just falling over right now? Or maybe you're driving across some huge bridge and you get that little thought in the back of your mind, what is actually holding all of this up? Well, today, we're going to pull back the curtain on the invisible science that keeps our world standing. It seems like such a simple question, right? But the answer? Well, it's all about this constant, hidden battle that's being fought against gravity every single second of every day. So, what's the secret to winning that fight? When you really boil it down, pretty much all of structural engineering is about solving one basic problem: how to get across an empty space. Seriously, think about it. The gap between two riverbanks, a huge valley, or even just the space for a window in a brick wall. The challenge is always figuring out how to bridge that void. So, that empty space, engineers have a word for it: a span. And the job of any structure, whether it's a simple wooden plank or a massive bridge, is to support its own weight, plus the weight of everything on it, all the way across that span without breaking. That is the number one most fundamental challenge. Okay, so how do they do it? Well, you can think of engineers as having this incredible toolkit, a set of basic fundamental pieces that they can combine in all sorts of clever ways that build pretty much anything you can imagine. Let's open up that toolbox and see what's inside. And here they are. These are the three heroes of our story: the beam, the arch, and the cantilever. It's wild, but almost every single structure you see is really just a smart combination of these three basic parts. Let's start with the one you see everywhere: the beam. It's really just a length of stuff, like steel or concrete, that's held up at both ends. You see that solid piece running across the top of a window or a door? That's a beam. Its whole job is to take the weight of the wall above it and carry it safely over to the sides, so the window frame doesn't get crushed. But of course, engineers didn't just stop with a simple rectangle. They figured out that for any beam, most of the stress, the real work, is happening at the very top and the very bottom. So they cleverly put most of the material right where it's needed most and took it out of the middle. And boom, you get the I-beam. This shape is ridiculously strong but also lightweight, and it's basically the steel skeleton for tons of modern buildings. All right, next up, the arch. The absolute genius of the arch is how it deals with weight. Instead of just trying to resist bending, an arch takes that downward force of gravity and transforms it. It turns it into a sideways pushing force called compression, and it channels all that weight down and out into its foundations. That's exactly why ancient Roman aqueducts are still standing after thousands of years. And our final tool is the cantilever. The perfect way to picture this one? A diving board. It's basically a beam that's only attached at one end, while the other end just hangs out there in space. Once you know what a cantilever is, I promise you're going to see them everywhere, from balconies on buildings to the wings on an airplane. Okay, so we've got our basic toolkit: beams, arches, and cantilevers. Now, let's see what happens when engineers start combining them on a massive, massive scale to create some truly stunning structures, like the world's longest bridges. Two of the most incredible bridge designs out there are suspension and cable-stayed bridges. Now, they might look kind of similar at first glance, but they work in totally different ways. On a suspension bridge, you've got these two gigantic main cables draped between towers, and then smaller cables hang down from those to hold up the road. But on a cable-stayed bridge, each cable runs in a straight line directly from the tower down to the bridge deck, creating that beautiful fan-like pattern. And just to give you a sense of what's possible here, look at this number: 1,990 meters. That's over a mile. That is the length of the main span of the Akashi Kaikyo Bridge in Japan. It's the longest suspension bridge on Earth, and it's just an unbelievable example of what happens when you master these principles. But here's the thing: building things up is only half the battle. To be a truly great engineer, you have to be just as obsessed with how things fall down. You have to know the enemy. And it turns out that enemy really only has three main moves. A structure can fail by fracturing, by bending, or by toppling over. Every single structural design is basically a defense plan against these three threats. First, let's talk about fracture. This one is a failure of pure strength. The easiest way to think about it is snapping a pencil. You apply too much force, the material just can't take it, and snap, it breaks. That's a fracture. It happens when the load on a structure is more than the material itself can handle. Next up is bending. Now, this isn't about strength. It's about stiffness, or rigidity.
The material doesn't actually break, but it changes shape too much when you put a load on it. Think about a flimsy plastic ruler. It bends super easily because it has very little stiffness, and in a big structure, that can lead to all sorts of problems.
So, bending itself can happen in a couple of ways. When you take something long and thin, like a drinking straw, and you push down on it, see how it bows outwards? That's called buckling. It's bending under compression. Now, if you were to pull on something and it bends, that's called flexing. Engineers have to plan for both. And finally, there's toppling. This failure has nothing to do with how strong or stiff the material is. This is all about stability. It happens when a structure is top-heavy or if its base is just too narrow. A little push from the side that a stable object would just shrug off could be enough to make an unstable one tip right over. So, when you put these two sides of the coin together, the toolkit for building things up and all the knowledge about what makes them fall down, you finally get to the very heart and soul of structural engineering, the science of stability. The core principle is actually pretty simple, but it's also incredibly profound. The ultimate test of any structure isn't just, can we build it? It's, can it stand up to every force that's going to be thrown at it over its entire lifetime? And that right there is the key takeaway. The best engineering isn't just about going bigger or higher. It's about having this deep, almost obsessive understanding of how things can fail, whether it's by fracture, bending, or toppling, and then designing every single piece to prevent that from happening. It's a constant, calculated fight against the forces of nature. So, the next time you're out and about, I want you to take a closer look at the world around you. Try to spot the beams, the arches, the cantilevers. Think about those invisible forces they're fighting off every single moment. Now that you know the rules of the game, what structure in your world seems the most impressive?